Hello, in this video we'll be discussing the solubility guidelines that you can use to determine whether an ionic compound is soluble or non-soluble in water at standard conditions. So essentially solubility is very much dependent on conditions, which you'll learn a lot more about in the second semester of general chemistry when you talk about thermodynamics. But for the gist of the first semester, you're really just dealing with standard conditions in water, and you're dealing with ionic salts. And this is because, if you remember in the previous video, we talked about double replacement reactions. And the majority of double replacement reactions that you'll see in general chemistry have to do with producing a precipitate, producing a solid as a product. And to determine whether you've produced a solid or not, in the theoretical sense, in the non-experimental sense, will depend somewhat on these rough solubility guidelines. And these solubility guidelines are going to be summed up by this idea of the rule of 4. And the rule of 4 just means that if the charges of both of your ions that make up your salt multiply together to equal a number that's 4 or greater, it's very unlikely that your salt will be soluble at standard conditions. It's likely to be insoluble, which just means that it just doesn't dissolve readily in water. So we're going to break it down step by step and look at a few examples that you'll come across to determine whether your salt will indeed be soluble or insoluble at standard conditions based on the rule of 4. And exceptions will be pointed out because there are several exceptions that do come up. So in this first category, we're going to look at the +1, -1 charges. So if you have any salt, I'm just using sodium chloride as an example here, but it could be any salt where you have a +1 and a -1 charge for your ionic bond, you're going to see solubility. Now I'm getting this from the fact that you see the +1 and the -1. 1 times 1 is equal to 1. 1 is less than 4, which is where the rule of 4 comes from. So if these two charges, +1 and -1, multiply together, ignoring their signs, ignore the plus and the minus, just multiply the numbers, 1 and 1. So you multiply 1 times 1, you get 1 as your product. And because 1 is less than 4, we'll generally say that the vast majority of these compounds are soluble. So I'll put a big check mark next to this. Any of these salts where you have this 1 and 1 are going to be soluble. A big exception though is silver chloride, AgCl. This is not soluble. In fact, it is very, very insoluble at standard conditions. So this is most definitely not soluble. So please note that AgCl is solid at standard conditions in water. So here is sort of our second category. So here we have a 1 and 2 for our compound. So here we're looking at the example of lithium sulfate. Lithium having a +1 charge, sulfate having a -2 charge. So if you multiply the 1 and the 2, like we did here, you'll end up with your product of 2. Again, 2 is less than 4, so these compounds are generally going to be soluble. And again, these are just examples, so this is not the only salt that does this, it's just an example. So we've got a +1 and a -2, multiply them, less than 4, we'll say this is soluble. So in this next group, we have the combination of +2, -1, so flipping it around from the previous one. and I'm using the example of calcium chloride, CaCl2. So again, just like the previous one, you take 2 times 1, so 2 times 1 equals 2, less than 4, so generally these are going to be soluble. But just like with the silver ion, the lead ion Pb2+, which includes PbCl2, PbI2, those are not generally going to be soluble. So in our final group we have the example of calcium phosphate. So we have the calcium ion, which is +2, the phosphate ion, which is -3, so 2 times 3 is equal to 6. 6 is greater than 4, so we'll probably give this an X. So these are generally going to be non-soluble, those whose charges multiply to equal 4 or greater. An exception to this would be magnesium sulfate, which has a +2 and a -2, so it equals 4 when you multiply them. Magnesium sulfate is generally soluble. So this is just like a quick way you can glance at them, and we'll now go over some of the actual official rules involved. So I guess sort of the bottom line, if you want to call it that, is sort of the generally soluble versus the generally insoluble. So things that are bonded to group 1 metals, so lithium, sodium, potassium, rubidium, and cesium, are almost always going to be soluble. Things that are bonded to nitrates are almost always soluble. Nitrates are extremely soluble. So anything bonded to NO3, I would call it soluble. Things bonded to Cl-, I-, and Br- are generally soluble, except for when it's Ag or Pb. So things bonded to these three things are almost always soluble, except when they're bonded to Ag or Pb, and we addressed that above. AgCl, Agi, Agbr, not soluble. PbCl2, PbI2, PbBr2, not soluble. So, generally things bonded to silver and lead are not soluble, except when they're bonded to nitrates, because nitrates are very soluble. So if you see lead nitrate or silver nitrate, think of those as soluble. Anything else, I would think of it as insoluble. And phosphates are generally going to be insoluble. So that's sort of your bottom line on solubility. Hopefully that clears up any confusion you might have as if something is soluble or insoluble. In the next video we'll begin talking about limiting and excess reagents, and we'll discuss a little bit of the math of that in a practice problem also.